So here's the thing. I mentioned that part of limit is close. So the word close can mean different things for different people. And so we run into this problem is that they said approaches, all right? So the word approaches is also very relative. Very, very relative. And we don't want you to just... It is a problem for me just to say as it approaches X. But you could say, oh, well, it's approaching it out here from here to here. So I went way far out. And then someone else is like, no, let's get minuscule. And so we get all these different terms when we talk about approaching. And so they said, well, we definitely need to make this more defined, okay? And in order for me to make this more defined, I need to give you more parameters. Because the truth is that if it is a function, every X is going to have a Y value. Or it's going to be undefined somewhere on there. So something's going to happen for every X. I'm either going to have a Y value or I'm going to have some reason why there's a hole or an asymptote there, okay? And so if I look at these things, and these are a bunch of, we got some Greek letters going on, but the C represents my X, okay? So they're saying, I'm going to give you a C. All of your functions, when you're looking at limit, are going to say the limit as X approaches C, some constant, right? So my X value that they've given me is some constant C. That's what this guy right here represents, that's C, okay? The L then, the L is my limit. So the L is just representative of my Y value when I actually approach C. Now remember, it's not necessarily what it's defined at, but that's how they're going to draw it here, okay? So if I were to come to C, and on a graph, I would go all the way up until I hit the graph, and that's where my Y is. We've known that since we could graph, okay? For every X, there's a Y, it's a coordinates, okay? And in this case, there's a hole, but still, I can see where the Y would be, all right? Now, here's the problem. They're just saying approaches. Well, I need you to define approach. So what they've done is they have said, I want you to go only so far away from C on the left and the right-hand side, all right? And they've given me these parameters. Now, they've defined it, so they've used epsilon and delta. These are just Greek letters that represent a range, okay? So, for example, you're building something, all right? And you have these specs in front of you, and they say, I need it to be 2¼ inches long, all right? You can really only measure that precision depending on what your tool is, okay? And so typically there's some give and take. Like you can be 1/16 of an inch off either way, and I'm okay with that. It'll still build my box the way I want it to be built. Any manufacturing plant's gonna do this. If they're manufacturing ball bearings, okay, for example, the ball bearing is gonna have a specific diameter that they want for every single ball bearing, but the truth is they actually have a parameter of error. Either this much bigger or this much smaller. And we're still gonna be okay, the ball bearing will still work for what it was intended purposes, okay? That's what they've done here with this delta, okay? First of all, this is the lowercase delta. You have been more familiar with uppercase delta, which is a triangle, okay? This is just Greek letters. So delta is legitimately just a variable, okay? We use X and Y. We use, when we're doing word problems, we use distance, rate, and time, D, R, and T, okay? So when you see a Greek letter in calculus, it's legitimately standing for some type of variable. What they're saying with this delta is we have C, the constant. Let's say X is approaching 2. And they're going to say on either side of 2, I only want you to get 0.01 away. 0.01 is your delta. Delta meaning how far away from C you can go before you call it the limit, okay? So that means in order to fall into those parameters, which are down here, so here's my C parameters on either side of C, delta, positive delta, negative delta, okay? This creates a window for what Y could be. You see that window at the top? And so you see the actual limit, and then you see this window on either side of the limit. And what they're saying is, as long as you fall in the window for the delta, the epsilon will fall in the window for the limit. Meaning, I'll take your answer, right? Your ball bearing falls within the percentage error ratio. It's okay to go, right? But if you don't get within that delta, that means your limit's going to fall out of the window acceptable range as well. That's what they started doing with limit. They said, okay, approaches is not good enough. We need to better define it. And so that is where you get the formal definition of it, which looks like this guy right here. Okay? Lots of words. Let f be a function defined on an open interval containing c. All they're saying is the x value that you're getting towards has to be in the interval that you're looking at. Well, obviously, okay? Except possibly at c. You don't necessarily have to be defined at c. You could have a hole in your graph. That is okay. And let L, that is the limit, be a real number. All right? That's all they've put the parameters on here. First of all, it has to be defined on the interval, not necessarily at C. You could have a hole there. That's okay. And your limit has to be a real number. We're not talking imaginary world here at this point. Okay? And then they wrote it like this. Well, then the limit as f of x here, of f of x as x approaches C is going to be L. What does that mean specifically? That means that for each epsilon greater than 0, there exists a delta greater than 0, such that if 0 is less than the absolute value of x minus c, which is less than delta, then f of x minus the limit is less than epsilon. Words, 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 okay? What they're saying is, what is x minus c? Well, x is the actual number you get to. C is the limit that they told you they were moving towards, right? Up here, x approaches c, right? So at whatever x value you land on minus what you were shooting for, okay? All right, so if I were to go back here, the distance away from the actual x value that I'm moving towards has to be between 0 and delta. I'm in the window. That's all this statement here is saying. From where I actually end up and where they wanted me to get to has to fall within that delta window. Positive or negative delta on either side, okay? If that happens, then my limit is going to be within that epsilon range, the window for my limit. That's all they're saying. And they're saying there has to be, for every delta, there has to be an epsilon. And remember, we're just talking x's and y's. Delta is just a value of x. It's just a variable for x. Epsilon is just a variable for y. So if we look back at our graph, really quickly, we're going to go through finding. This is really... So the definition, the actual definition of limit is something I want you to know, that for every epsilon, there is a delta that exists that would get you close enough to what they want, pretty much. But in actuality, you're going to use some application methods to find limit. You're not going to actually use this formal definition to find a limit. It's just so that you understand what approaches mean and that what epsilon delta stand for. They stand for that range of x, range of y, okay? All this theorem is an existence theorem, okay? So there's an existence theorem for a continuous function. If there is an x, then there is a y that exists that corresponds to the x. It's an existence theorem, okay? That's what limit is. If you have an epsilon, then there is a delta that exists. If you have a range for your x value, then you have a range that naturally exists for your limit. That's all this theorem says, okay? It's an existence theorem. This does exist, okay? And so all we're doing here is saying, well, if epsilon is this, what is delta? So this one, they said, find the delta for a given epsilon. Given the limit, x as x approaches 3 of 2x minus 5 equals 1. Find delta such that 2x minus 5 minus 1 is less than 0.01 whenever 0 is less than x minus 3 less than delta. Blah, blah, blah. What did they just tell me? All right, so if you look back at this definition here, okay, they have given me the epsilon. So look at the second part of the definition on page 52. It is f of x minus L. So this is f of x right here. F of x minus L. Everybody see that? Okay. And then this is your epsilon. That's your epsilon right there. Then they said, here is your x minus c. Remember, c is whatever x is approaching. So you can see that's what your c is. You can see this is your f of x right here. And this is your L, right? So they've literally just plugged it in. Function minus limit, that difference is less than whatever epsilon they've picked. They want you to be within a 0.01 range. That's why it's absolute value, positive or negative. Either way, they want that range to be there, okay? That's your margin of error, so to speak, okay? So then they're asking you, if that's your margin of error, that's how close to the actual limit I want you to get, how close to 3 do you have to get to fall within the margin of error for your limit, okay? So they gave you the margin of error for your limit. They want the margin of error for your x, okay? So what you basically want to do is you want to make your function piece of it look like what you're moving towards. So I'm going to try to make this guy look like this guy, and whatever it's less than is going to end up being my delta. All right, so I'm going to manipulate this function and simplify it until it looks like that guy on the right. So the first thing I can do is I have parentheses. Do I need to distribute anything? No, it's a 1. So I can just take those guys out of the parentheses, right? So far, so good. Basic algebra. What else can I do to simplify it? I just took the parentheses out because there's nothing to distribute. Yeah, -5 minus 1. How would I write -5 minus 1? Yeah, -6. 2x minus 6 is less than 0.01. All right? Can I factor anything out of that? Yeah, a 2 can factor out. It is a positive 2, and it's an absolute value. We're all good to go, okay? So I can factor a 2 out, no worries. So I'm going to take a 2 out of here, and I'm going to have x minus 3. All right? What am I trying to make it look like? This guy right here. I'm almost there. What do I need to do? Divide both sides by what? 2. So I am going to divide both of these sides by 2. So I have x minus 3 right here. What is 0.01 divided by 2? It's like 10 divided by 2. You can just put a 0 here, right? So does this guy look like this guy? Yes, it does. So then what does that make my delta? It's less than 0.005. My delta then is 0.005. What did this tell me? What did this tell me? This said, okay, I want your limit to have an error margin of 0.01. Positive or negative. Either way of the actual limit, you can be within 0.01. That's as far away from the limit as I want you to be. So then how close to 3 do I have to get? I have to get within 0.005. So I can go up to 3.005 and down to 2.995. Okay? But that's the biggest range I can get for x. I have to get that close to 3 to have a valid limit. Does that make sense? That's all you're doing with these. This is an existence limit. An existence theorem. So all you're doing is saying, okay, I know it exists. They're going to give me this. If this is this, then that means my delta has to be this. So if the epsilon is this, I'm going to manipulate this guy to figure out what my delta is. Okay, that's all you're doing with these. Make sense? Questions? So the limit, it has to be, as I'm approaching 3, I have to get this close to 3. So on either side of it. So basically I can be 0.2995 less than my actual constant, which is less than 3.005. This is my range for as I move towards it. That's what it means, approaches. I have to be that close to it before I can call a limit. So if I were doing a chart, I would want to make sure I'm charting that close to it. I can trend outside, but I'm charting, right? Movement-wise, it's just defining the word approaches. It's making it more specific. So the author is saying, okay, they said approaches. I want you to get this close. That's what I mean by approach. So you have the limit as x approaches 2 of 3x plus 2, and I'm going to go ahead and tell you that this is 8, okay? So this is your f of x and your L, right? This is your f of x. This is your L. Your epsilon they gave to you. What is your epsilon? Look in your instructions. How close do they want that limit to be?
0.
Yeah, so the epsilon is 0.01. So then what is your delta? And by the way, remember this is your C.